Hey guys, we're going to start section 3.3 in this video, which is about solving formulas. So we've already kind of seen how to do this in the past. So with formulas, if we have something say like I equals PRT, so just a good practice would be to make sure that you know what everything means, right? So in this case, I would stand for interest, P would stand for principal, and what is the principal? That's the amount of money being put in the account. R would stand for the interest rate, and T would stand for time. Time could always be in months or years. I think a lot of times when you look at these problems, it's probably going to be years. So whenever you have a formula, in general, if you're asked to do stuff with it, you want to make sure you just kind of know what everything means. So I just want to play around with this formula just to kind of set up what are we actually going to do in this lesson. So let's start with, suppose you have $500 to invest. You put it into a simple interest savings account with 5% interest rate and plan to leave your investment alone for 2 years. How much interest will you accrue in this time? So what a question like this is asking you to do is to just straight up use that formula, that I equals PRT. So your principal in this case is 500. Your rate as a decimal would be 0.05. And then the time would be 2 years. So this would be a nice straightforward way of kind of asking this question. And this equals $50. But there are other ways that we could kind of ask questions about this formula. So in B, now instead let's say that you would like to accrue the same amount of interest from part A, but you want to leave the same principal in the bank account for 5 years. How can you figure out what interest rate you'll need in this scenario? So a couple of things we have to kind of break down with this. It says that we want to leave the same principal, so that would be the $500, and you also want to accrue the same amount of interest. So you kind of have to break this problem apart, and you want to do this for 5 years. So this is asking, what interest rate do you need? Now remember, we're working from the formula I equals PRT. So what information do I have for this particular problem? Well, I want the interest to be the same, so I still want to make $50. I want my principal to be the same, so that's going to be 500. And I want my time to be the same. So I don't know what I want for my rate, right? But I know that I want my time not to be the same. I want my time to be 5 years. So I'm following my I equals PRT and putting in what information I have, except now this formula looks very different from the last one, right? So in this one, this was nice and straightforward. We could just multiply everything together, bada bing, bada boom. This one, now we actually have to go through and solve for R, and we have the skills to do that based off of everything that we've done in the last section. So if I want to solve this, first I can just do 500 times 5, so this is 2500 R, and now if I divide both sides by 2500, so this will be your interest rate. So I get, oops, sorry about that. And oops, I just realized I'm kind of going off the page here. Sorry, this is going to be my R. So my R in this case is going to be equal to 0.02. So I need an interest rate of 2%. Now on to the last question. Instead of the 5 years that was listed in part B, what would happen to this formula if we wanted to leave the principal in the bank for T years? How would this affect our answer for the interest rate? Okay, so this question is definitely a little bit strange, right? Let's just kind of break down everything. So it's telling us that we want to have a very similar setup to the last one, but we basically want to do the same thing we did before, but now instead of putting in a number for years, we want to put in T. So here's what this is trying to get at. I want to keep everything else the same, but I don't want to put in the 5 for the T. I just want to put in T for T. So here's the thing, I still want to solve for R. So if this is now what I'm inputting instead of what I did up here, how does that affect my interest rate? How does that affect things? Well, you're still going to divide, right? But what are you actually going to divide by? Well, this is 500 times R times T. I want to get R by itself. So to do that, I actually just have to divide out the stuff I don't want, i.e., I can actually just divide out 500T from each side like this. And now what I get for my R is going to be 50 over 500T. And can I simplify that anymore? Well, I can. So this is 1 over 10t. So now this would actually be the interest rate for your r. And the idea behind this is actually what we're going to be doing in this section. Previously, what we've been doing is either working with formulas where we just kind of nicely input everything, or, you know, in the last sections, we've been solving for a particular letter. Now where we're going in this section is I want to actually just put in multiple letters, but solve for only one letter. That's the idea in this section. So let's go to the next page. So now what we're going to do is just talk about how to solve formulas, much like that last example we were just working with. So I'm going to give you a formula. Better yet, I'll make it 2. And what I want you to do in all of these, we're going to solve all of these for x. So in these two problems, I have kind of the two ways that, kind of the two most basic ways this can shake out. So in the case of A, all I want to do is isolate x. And notice this is 4 plus x. So how would I get x by itself? Well, I would just subtract 4 from each side. And now the thing that's going to be strange about this that you have to get used to is you can't do y minus 4. These are not like terms. So your answer is just going to be, and it's totally right, y minus 4. X equals y minus 4. So this is kind of one way you're going to approach these problems. And then another way that you might have to approach this is something that occurs like this. So now in this one I have 3 times x equals z, and I want to get z by itself. So what operation do I have to do to get x by itself? Well, I would just divide each side by 3. So here's the basic idea. So let me give you one to try on your own. Here I've got 3y plus 4x equals z. I want you to pause the video and try to solve for x and then hit play when you're ready to see the solution. So the first things first, I really just want to get this x by itself, and x is attached to the 4, so we'll just have to work on getting 4x by itself. So to do that, the first thing that I need to do is get rid of the 3y, and to do that I will subtract it, right? Y is currently being added to 4x, so to unravel that we subtract it off. So now I get 4x equals z minus 3y. Next step now to finish getting x by itself, well notice this is 4 times x, so how do I get x by itself? I need to divide out the 4. So I want to divide now each part of this problem by 4, and I'll get to x equals z over 4 minus 3y over 4. Or an equivalent way that you can write that answer would be 1 over 4 times z minus 3 over 4 times y. It doesn't matter which way you want to write that. Okay, so let's have you try another one. I still want to solve for x, and now I've got 3xz plus 2y equals 5. So pause the video and hit play when you're ready. So in this one, so notice here's where my x is, and it's attached to the 3 in the z. There's nothing I can really do about that right now, so all I can really focus on is just trying to isolate this piece. So to isolate that, I need to get rid of the 2y. So to begin, I will subtract off the 2y from each side, and now I get 3xz equals 5 minus 2y. And then to finish this off, so this is 3 times x times z. I want the x by itself, and everything here right now is being multiplied together. So to finish this off, what I'm going to do is just divide out the parts that I don't want, which means I'm going to divide out the 3z. And I just want to divide each part by 3z. So in the end, I get x equals 5 over 3z minus 2y over 3z. Now, in this case, unlike the last one, since we have letters in the bottom, I can't break this out. It would be wrong. I'll write this in red just to make sure this is clear. This is wrong. This would be wrong. That is not true, right? If the z were up here, that would actually mean what you have. If this were the case, this would mean that you have 5z over 3. So you can only break this out like this if you have that letter in the top. So in this case, it doesn't really make any sense. So that's the idea. Okay, so let's do some more. Okay, so same directions. You want to solve for x, hit play when you're ready. So in this case, my x is right here, right? So I have this 1/3 xy. So what I want to do is first I want to just get the 1/3 xy by itself. So I'm going to start by adding the 5z to each side. And there's a little bit of a plot twist in this one in that I can totally add 1/3 z plus 5z. These are like terms, so this will actually equal 7z. All right, and now we have the old dreaded fraction. So let's just take this in pieces. So I know in the last one we just divided out the stuff we didn't want, but in this case the fraction kind of throws us off, so it might be in our best interest just to take this slowly. So to get rid of the fraction, in general, when you have something set up like this, you really just want to multiply everything by 3, right? Because that will cancel out your denominator in this case, and whatever you do to one side, you do to the other. So what will all of this become? On this side, I have just xy, which is nice. And then here, I've got 7 times 3. That's 21. So this is 21z. Okay, take a deep breath. We get rid of the fraction. Now I have to get x by itself. So now I'm just going to divide out that last part I don't want. So ultimately, I get 21z over y. And there you go for that one. All right, so I have a couple more for you here. Just some other kind of trickier ones. So let me show you the next one. Okay, so now there's another little plot twist in this that you're going to have to figure out what to do. So pause the video, give this a try, hit play when you're ready. So in this case, there's actually 2 different ways you can do this. So first I'll show you the longer way, but I'll show you both, so if you did it a different way, just hold on. So you may have decided to distribute, and that's totally fine. So then you get 2x plus 6y equals w, and then you can just go about solving for x. So I subtract off the 6y. I get 2x equals w minus 6y. I divide each part by 2. I get x equals w over 2 minus, well, 6 divided by 2 is 3, so this just becomes 3y. Here is case 1. Now, you may not have decided to go that route, so I wanted to show you actually the more efficient way to do this. So the other route you could have gone is said, well, this is this times all of this, and I don't really want to distribute this. So the alternative way you could have started this is you could have just divided this by 2. Now, if I divide that by 2, look what happens. The 2's drop out, and now I've got x plus 3y equals w over 2, and now I can pretty easily finish solving for x, right, by just subtracting the 3y. So I get x equals w over 2 minus 3y. Hey, it's the same solution from before. So it doesn't matter which way you decided to do this, 6 one way, half a dozen the other, but that's kind of the idea behind this. Okay, so I have one more for you guys. Okay, so for this last one, of course I had to put another fraction in there because I'm mean. So go ahead, pause the video, think about what you know, hit play when you're ready. So there's more than one way you can deal with this. You could distribute. I think that's maybe a little bit more difficult in this case. Usually when we have an equation, we like to clear the fraction, right? So if I wanted to clear the fraction, I could just multiply this by 3, and actually that whole thing goes away because the denominators would drop out here. So now I get 2 times x minus c, and this will equal, so 5 times 3 is 15. So there you go. Now, from here, you can really take either case. You can go ahead and distribute like I did in the last problem. I showed you how to do that. Or you could just divide by 2. Just for the sake of time, I'm going to go ahead and divide by 2, but you'd get the same thing even if you distributed. So now I've got x minus y equals 15y over 2, and then I can just add the y to each side. So now I've got x equals 15y divided by 2. Oh, sorry, I changed this, didn't I? My bad, my bad. Bad teacher, my bad. Plus c, okay, there we go. And there, okay, plus c, okay. That's what I meant to do. Sorry about that, I switched the letter at the last moment. Okay, so that's kind of the idea behind that. And so that'll do it for this section. I'll see you guys next time. Thanks for watching.